This video is going to go through grouping like terms, writing equations, and solving using substitution. So grouping like terms. We have a few definitions that we covered in the previous video that are important to this concept. So terms have one or more pronumerals or can be just a number. Non-like terms have different pronumeral parts or pronumerals raised to different powers. Like terms have the same pronumerals. They can have different coefficients. They can have pronumerals in a different order, so AB is equal to BA, and their pronumerals are raised to the same power. We have three examples at the bottom of the page. So our first one is 7x plus 8y minus 2x plus 5y. If I have a look at my first term, 7x, the like term is negative 2x. They have the same pronumeral, but they have different coefficients. If I have a look at my second term, 8y, a like term is 5y. They have the same pronumeral, but they have different coefficients. So if I rewrite this, I have 7x minus 2x plus 8y plus 5y. So in this line, I have grouped my like terms. I can then simplify by performing the operation between the like terms. So 7x minus 2x is 5x. 8y plus 5y is 13y. I'm finished there because 5x and 13y are non-like terms, so you cannot complete any further operations. Our next example has 8x squared plus 7x minus 2x. So 8x squared, if I go through and have a look at the other terms, 7x, negative 2x and 3y, none of them have the same pronumeral raised to the power of 2 as 8x squared. So therefore, there are no other like terms. If I have a look at 7x, negative 2x is a like term. And my final term, 3y, it doesn't have any like terms in this example here. So if I simplify that down, I've got 8x squared. Because my like terms are already grouped, I've got 7x minus 2x, so it'll have plus 5x and then plus 3y. In that final line there, I don't have any like terms, so therefore I've simplified that expression as far as I can. The final example on this slide, I've got 4xy as my first term. Now, because as we previously covered, an algebraic convention is that the pronumerals can be written in a different order, that means that negative 2yx is a like term because it could also be written as negative 2xy. Our other two terms are 2k and 4m, and they are unlike terms. We then need to group our like terms. So we have 4xy minus 2xy plus 2k plus 4m. We then simplify that expression. So 4xy minus 2xy is 2xy. And then we have plus 2k plus 4m. How to write an equation. So it's really important when we're writing equations that you read worded problems carefully. You need to underline values that need to be given a variable and define what that variable represents. You need to circle words that tell you operations, and then you need to write the equation. So our example in this case is a number is multiplied by 7 and 5 is subtracted from the product. The answer is 37. What is the number? So our first step is to underline values that need to be given a variable and define them. So a number. This is our unknown. So we need to choose a variable. So this can be any letter or symbol. In this case, I'm going to use the letter n. So n represents a number. So I've defined my variable as being representative of a number. You then need to circle any words that tell you operations. So multiplied, subtracted, product. We then go through and reread the question. So a number is multiplied by 7 and 5 is subtracted from the product. The answer is 37. What is the number? And I write the equation. So a number is multiplied by 7. So remembering that my number is represented by the variable n, So n is multiplied by 7. 5 is subtracted from the product. So the answer of n times 7, 5 is then taken away from, so minus 5. The answer is 37, so that equals 37. I then need to rewrite my equation so that it is following algebraic conventions. So n times 7 would be written as 7n, then we'd minus 5, and it would equal 37. And that is how I write an equation. How to solve equations using substitutions. So there are many situations where you'll be given formulas or equations where you know the value of the variables. In this instance, you need to substitute the value into the formula or equation in order to get your answer. So our first example is the area of a circle, and it is found using the formula A equals pi r squared. And we want to know what is the area of a circle that has a radius of 3. So that is telling us that the unknown value r is going to be 3. So we write our formula first, so A equals pi r squared. We know that r is 3, so that means that we are going to substitute 3 in where r is. So we've got pi times 3 squared. Now 3 squared is 9, so this is the same as saying 9 pi. You can then use your calculator to do 9 times pi, and you'll get an approximate answer of 28.27 centimetres squared. Our second example is using the circumference of a circle. So this is found using the formula of 2 pi r. And I want to know the distance a bike has moved in 4 revolutions if its wheel has a radius of 20 centimetres. So we can find the circumference of the wheel, and then we need to times it by 4 to work out how far it has travelled. So our circumference equals 2 pi r. Now our radius is 20 centimetres, so I need to replace r with 20. So we've got 2 times pi times 20. Now we can do 20 times 2, which is 40, so our circumference of one wheel is 40 pi. So if I want to know 4 revolutions, that means that I need to do 40 pi times 4, which is 160 pi. You can then type that as a calculation into your calculator, and you'll get 502.65 centimetres. So in 4 revolutions, that bike will travel 502.65 centimetres. On this slide are some common area and perimeter formulas that you may need to use and that you also may see in your NAPLAN test. So we have a rectangle, square, triangle, trapezium and circle. And in your own time, if you can have a look at that table, have a look at the formulas and the variables that are used.